This is the input box routine for showing the value boxes. It's subprogram 7, tab 11. It starts by setting an XY position of 50-30, a font of bold 20 points, a color of black, and then it sets up a numeric box. It has 5 positions. 3 will be for the digits, 1 for the sign, and 1 for the letter exponent. It's assigned a click number of 39, therefore it's an updatable box. And the value it's to update is the global register K. Right after it does it, it makes sure that K is a positive number by taking its absolute value in itself, and that it's an integer by rounding it. Then it adds 125 to the value of X, that means it's moving it to the right, and sets up 3 control registers. Control register L is the index value to add when it goes to a new row. Control register M says how many columns there are, and control register N tells it how many rows there are. Then we have the box N, which has 123,000 added to the number of places. That tells the action that it has to check the values of L, M, and N. This is not just for one value, but since there are 5 columns and 2 rows, there are 10 values involved. Well, there are 7 places for each. 5 of them will be for the digits, 1 for the sign, 1 for the letter exponent. It's assigned clickable number 21. Of course, there have to be 10 of them, so it's 21 to 30 are the clickable numbers. And here's the list where the 10 numbers are. They're in the value list. Well, we go on. It sets up another XY position of 10, 100. And it does the 3 control registers again. L is telling it to add 10 to the index when it goes to a new row. M tells it that there are 10 columns. N tells it there are 10 rows. Now there's 100 values. The font is sent to bold 13 points, and here it boxes the N. 123,000 was added to the number of places, so this action knows that it has to look at L, M, and N in order to produce the matrix of boxes. 6 positions, so 4 are for the digits, 1's for the sign, and 1 is for the letter exponent. It's assigned a clickable number 101. Well, it's really 101 to 200 because there are 100 values in matrix A that it is going to display using this box N action. Now, the next instructions we're coming to are for the matrix inversion. We're not going to go over matrix inversion. We're going to just skip through these until we get below the green. Alright, here is the end of the invert to matrix. So now we continue. It sets the value of L to 10. It sets the value of N, control register, to 1010. Well, not really. It's setting it to 10. The 1000 was added to tell it that it's not multiplying 2 vectors in the next instruction, but it's multiplying 2 matrices. So it had to have 1000 added to it to let this mul, which is the multiply instruction for matrices, the L's for lists, to tell it that these two are matrices and therefore the answer is a matrix. And it only needed to know n of 10 because the number of columns and rows is the same. So it knows it's really a 10 by 10 matrix. Then it goes on and sets an XY position of 10 to 75 and gives 3 more of these control registers. L for the amount to add to the index, M for the number of columns, N for the number of rows, sets bold 13 point for the text, and says box this matrix B. So the boxes are going to have 6 positions each, 4 for the digits, 1 for the sign, 1 for the letter exponent. And here the click number is 0, indicating these are not updatable boxes. You see, matrix B is the inverted matrix. They're not updatable. The only updatable is matrix A, where the values can be entered. Well, after that, it's going to go around a loop for every value in matrix C. It's going to go around the loop and check to see if any value in it is really small. If it's really, really small, it's going to say it's the same as 0. If it's greater than a small number, it says it's going to go down here to BD. But if it's very tiny, it's going to set it to 0. If we didn't do this, our inverted matrix could end up saying that, oh yes, there's a value at this point. It's 0.0000000001. Well, that's going to make our identity matrix look really stupid if it does that, right? We want it only if the value has some significance. Well, it checks every one of them. Now I'm going to up the screen some. Alright, here's where it did that. Now we're going to set X and Y, 700, 180, a font of 4 for bold, and just 8-point size numbers. As you remember, the identity matrix was quite small. Here it does it, the box numeric, and it adds the 123,000 to say that it needs the values of L, M, and N. Well, they're not right here, are they? That's because it can use the values of the previous matrix. For the L, how much to add to go to the next row, and how many columns there are, how many rows there are, is the same as it used previously. So it doesn't have to give them again. Well, there's only 4 places for this identity matrix, matrix C. 2 for the number of digits, 1 for the sign, and 1 for the letter exponent. And again, it's 0 for the click number because they're not clickable. You cannot update them. It's the identity matrix. It's the product of matrix A times matrix B. It's not updatable. Then it sets X and Y to 290/80, a font, bold, 18 point, color dark red, and starts putting these text lines. It puts matrix A above matrix A, word matrix B above matrix B, matrix C above matrix C, and then it also shows that A equals B, well, A times B equals C. Alright, that's the end of the value boxes for input box.